All right, we're going to talk about solving trig equations. We've done some real basic ones, but this chapter we're going to be using some of these new trigonometric identities to simplify equations so that we can solve them. A couple key things to solving trig equations is you want to only have one trig function. So if you've got tangent and secant, you need to somehow turn that into where you only have one or the other, or maybe you can convert it so you only have just sine or something like that. But you only want one trig expression in your function, okay, before you start actually trying to solve it. So use your trig identities to get just one trig function in the whole equation. You know, it could be a sine squared and a sine cubed or something like that, but at least you're only dealing with sine and not multiple trig functions. After you get that, all solving techniques can be applied. So it might be a quadratic. It will look a little bit different. Okay, so once you get your only trig function, then all the solving techniques that we've learned in algebra can be applied. Okay. Another thing is, once you solve, you're solving for an angle, and there's going to be more than one angle that has that sine or cosine or tangent value. Okay, because just looking at our unit circle, if I'm looking for the value where the sine is a half, that could be here or here. Okay, that pi over 6 or 5 pi over 6. So I'm going to get two answers, and they're either going to give you a range. They're going to say, okay, we want all the answers from 0 to 2 pi. Or they'll just say, give us a general solution. So I'm going to go through what both of those mean with a couple examples here. So here's my first example. So when we're solving this one, we're just going to go through the steps, okay? When you're solving an equation, you're trying to get x alone. And the way you do that is to do the inverse operations as they come. So one thing to think about is, if I knew what x was and I were to plug it in here, the first thing I'm going to do, okay, is I would multiply by 2, then I would subtract 7, so I would do times 2 minus 7, and then I would take the sine of it, and then I would square it, and then I would multiply by 2/5, and then I would subtract 5. So in order to undo this, to get x alone, I'm going to do these opposite operations in the opposite order. So that means since I started with minusing 5, the first thing I need to do is add 5, and then multiply by 5 halves, and then square root it, and then do the inverse sign, and then add 7, and then divide by 2. Okay, and that's the order you have to go in. So if you get confused on which thing you have to do first, just write these steps out, okay? Here's x. If I knew what it was, I would times by 2 minus 7, take the sign, square it, times by this, minus this. Write those down and go in the opposite order, opposite operations, okay? Because now I know exactly what I need to do. I need to move the 5 over first, okay? So I have 2/5 sine squared of 2x minus 7 equals 5.2. Then I need to multiply by 5 halves because that will get rid of this. Okay, so that cancels this. I get sine squared 2x minus 7 equals, now 5.2 would be the same as 26/5 times 5 halves. It's going to be 26 halves, which is going to be 13. Now I need to square root both sides to get rid of the squared, because remember, sine squared of something is really like writing this. So the squared is actually outside, so you have to get rid of the squared before you can get rid of the sine. So my square root, so I get sine of 2x minus 7 equals the square root of 13, which is going to be 3 point something. I have the calculator here. We won't use it just yet, but I'll have it up and ready. So let's just leave it as a square root of 13 for now. I need to do the sine inverse now to get rid of the sine. So I'm going to do sine inverse on both sides. So now I got 2x minus 7 equals sine inverse of the square root of 13. All right, now here is where your range comes into play, because this is going to be an angle. Okay, sine inverse trig functions give you an angle. If they want just the angles between 0 and 2 pi, okay, I'm going to type this in and get a number out. Okay, so I'm going to do sine inverse of the square root of 13. Oh, that's not working because that's bigger than 1. I'm going to have to change my equation here. I do get 13. Yeah, this one's not working because you can't take the sine inverse of a number that's bigger than 1. And square root of 13 is bigger than 1. It's like 3 point something. Okay, so let's just change this. If you ever get this, you just say no solution, because you can't have a sign that's bigger than 1. So we'll just change it a little bit to make it work. Let's say the square root of 0.8, just so we can go through the steps here. So I'm going to do the sine inverse of the square root of 0.8. And I get this. Now this is radian measure. Okay. And radians are in pi. Pi is 3.14. And 2 pi let's see. 2 pi is like 6.283. So now this is just giving me a number. I'm looking for x values that are between this range, so I can keep going at this point. But what I want to do is recognize that there's more than one answer for this one right here. Okay, so I would get 1.107, okay, plus or minus 2 pi, because this is one answer that I'm getting, and if I went around the circle 2 pi, I'd get another answer that would give me that also. Okay, so 1.107 is somewhere around here, so it's this some angle up here. Okay, because this is half of pi, which is 1.57. So this is 1.107. Okay, we'll say that. So that's an answer for my sine, but I'm also going to have this. Okay, and I need to figure out what this angle is, because that's also going to be an answer. Well, the way I get that is these angles are going to be the same. So if I take pi and subtract my answer, that'll be another answer. So I'm going to take pi and subtract the sine inverse of the square root of 8, or 0.8. So I also get this. So that's another answer I have to write down. 2.034 plus or minus 2 pi. Now these are the two places. And they're the only two places, because if I go anywhere else, you know, down here, I'd have the negative sign value, and that's not what I want. Okay, so now I've still got to solve for x. It's important that you add these plus or minus 2 pi on before you solve from the inside part of your trig function. So I'm going to add 7. Okay, so if I add 7, I get 2x equals 8.107 or 9.034. And then I need to divide by 2. Now, both these have plus or minus 2 pi on them. If I divide by 2, that divides everything over here by 2. So this becomes 4.0535. And this becomes 4.517. Plus or minus, now this has been divided by 2 also. So now it's plus or minus pi. Now, if we want a general solution, we would just put an n on here, because anytime I go pi away, so n is just an integer. If I go 1 pi away, I get another solution. 2 pi away, I get another solution. 3 pi away, I get another solution. Okay? So this would be your general solution. If you want specific solutions, like between 0 and 2 pi, you need to just add or subtract pi until you get all the solutions that are between this 0 and 2 pi. And remember, 2 pi is 6.283. So these are both solutions. So I get 4.0535, 4.517. Now if I add pi to this, 3.14, that's going to be 7, which is bigger than 6.28. Same with this one. So I can subtract pi. So I'm going to subtract pi. And there's another solution. Okay, because that's between 0 and 2 pi. So there's another solution. 0.9119. I'm going to subtract pi from this other one. 4.517 minus pi. There's another solution. 1.375. Okay, these are the 4 solutions that are between 0 and 2 pi. Because if I subtract pi again, I'd be a negative. I don't want negatives. I want to be between 0 and 2 pi. So these are the 4 specific solutions between 0 and 2 pi. These would be my general solutions that would create an infinite number of solutions. Okay, every integer I put in for n was going to give me another solution. So actually another 2 solutions. So let's look at another one here. All right, in this example, I've got 2 trig functions. So I've got a sine and a cosine, and I don't want that because that makes it hard to solve. Okay, so what I want to do is I want to change one of these into the other. Cosine doesn't turn into anything because remember, we can always turn everything into sines and cosines, and cosine could turn into 1 over secant, but that's not beneficial to us, so that's going to stay the same. Sine squared, since it's squared, hopefully that's triggering your Pythagorean identity. Okay, so I'm going to turn this into 4 times 1 minus cosine squared x. Okay, I'm going to distribute the 4. Right now, I've got cosine squared and a cosine. Okay, this would be the same as if I had a squared plus some a plus some constant. All right, it's quadratic because I've got a squared variable, a non-squared variable, and a constant term. So when it's quadratic, I want to move everything to one side and get it equal to 0. So I'm going to move all this stuff over to the other side. So this will become positive 4 cosine squared x. This would be minus 4 on both sides, so that would become minus 3. This equals 0. Now, anything that you could usually do with quadratics, I can do with this, okay? So, for example, I could do the quadratic formula. Except, when I do quadratic formula, it wouldn't be what x equals. It would be cosine of x equals -b plus or minus the square root b squared minus 4ac. over 2a. So I'd get two answers, and then I have to do inverse cosine to both those answers. Okay? I'm not going to do quadratic here because I'm pretty sure this is going to factor. So what I'm going to do is try to factor this. So I could have 4 cosine x and cosine x, because that would get me 4 cosine x squared. Then I need 3 and 1, and I need a difference of 2. Well, if I put 3, I'm going to get 12 and 1, so that's not going to work. If I put 3 here, I'd have 3 and 4, and that is 1 apart. So that's not going to work. So let's try doing 2 and 2, because that'll also give me 4 cosine squared x. Now if I put 3 and 1, this will be 6 and 2, which is 4 apart. And that's not working. 4 and 1 didn't work. Let me just double check the 4 and 1. Yep, so I am going to have to use quadratic here. Okay, so quadratic. So this is what cosine x will be. Negative b, so negative 2. Remember, this is a, b, c. Plus or minus the square root, b squared, so 4 minus 4 times a times c divided by 2a. So inside here, I'm going to have 4 times 4, which is 16, times 3, which is 48. And since it's negative, negative, that's going to become positive. So we have negative 2 plus or minus the square root of 4 plus 48 over 8. 4 plus 48 is 52. So negative 2 plus the square root of 52 over 8. And negative 2 minus the square root of 52 over 8. 52 breaks down into, let's see, it'd be 2 times 26, which is 2 times 13. So this is negative 2 plus 2 squared at 13 over 8. Negative 2 minus 2 squared at 13 over 8. I can reduce all these by 2. So I get negative 1 plus the square root of 13 over 8. And negative 1 minus the square root of 13 over 4, not 8. So these are my two answers. This is what cosine x equals. So this isn't even what x equals yet. I need to now figure out what cosine x equals. So I need to do the cosine inverse of both of these. So x would equal the cosine inverse of this. Let's bring up the calculator. So cosine inverse of, put my numerator in parentheses here, negative 1 plus square root of 13 divided by 4. We get that. Let's just go and change this to minus. Oh, and I get a domain error. Okay, so what that means is whatever I'm getting here is outside of 1. All right, because the square root of 13 is 3 point something. And so if I take negative 1 minus 3 point something, I get something that's bigger than 4. So I'm taking something bigger than 4 and dividing by 4, which will give me something bigger than 1. So that's why I'm not getting a cosine inverse for this, because it would be bigger than 1. And cosine can't be bigger than 1 because of our unit circle. Okay, the biggest cosine value is here at 1. The lowest one is here at negative 1. Okay, so this would be something that's smaller than negative 1. So that's an extraneous solution. So I'd really just have the plus answer. So x equals 0.86 1, 4. Now, if they said, what's the general solution? I'll put, okay, well, that's plus or minus 2 pi. If they want only the solutions between 0 and 2 pi, okay, it would only be this one. Okay, because if I add 2 pi to it, that's going to be something bigger than 2 pi. Okay, if they gave me some other range, I would just take that accordingly. But here's your general solution. This would be the one answer, the one angle between 0 and 2 pi that would work. Okay, and that's how solving trig functions go. I'll have more examples in the future videos that go more into this plus or minus 2 pi. You won't have too many of these in your first assignment.